go. So I want to be able to withdraw $50,000 each year for 25 years. My account earns 9% interest. I want to figure out how much do I need at the beginning, how much total money will I pull out of the account, and how much money is interest. So we did something similar to that earlier, but this one's the reverse. Here, I know what the withdrawal is. I don't know what to start with. So if we look back at our cheat sheet, I know the payment here. So I'm in this payout annuity, the second to last line, and that'll help me calculate what I should start with to be able to use that payment. So let's make a note of what we know here. So this is a payout annuity, which is a retirement fund that we're pulling out of. So this here, my withdrawal, that is my D. So I have D, it's 50,000, 25 years, that would be my N. I'm doing it each year, so that means my K is 1, which is nice. And my R is 9% or 9/100ths. And so then I need that PN formula because I know D. And the formula said PN is, let's make sure I get this right, the D times parentheses 1 minus parentheses 1 plus R over K to the parentheses negative KN, close, divide by R over N, and some calculators need that in parentheses. Did I really get that right? It's this one right here. Got it right. So then
like R over K.
Oh, this should be R over K. Thank you. Yeah, sometimes I like to write little n for the monthly thing, so excuse my mistake there. All right, so then plugging in, I'm going to have 50,000 times 1 minus 1 plus, parentheses are necessary, 9% as a decimal over 12 to the power negative 12 times 25. Oh shit, I lied. It's not 12, it's yearly. I get so used to monthly calculations, which is the most common. Let's fix that. Let's make it red to re-emphasize that. Where else? I screwed it up over here too. On eraser. There we go. 1 is 1 yearly. All right. So hopefully I remember that now. Those parentheses divide by R over 1. I could just write R down there. Dividing by 1 doesn't do anything. Technically, we're doing that. All right, calculator time. So I've got fraction 50,000, that's right, times parentheses 1 minus, parentheses 1 plus, and dividing by 9 is kind of boring, by 1 is boring, so I'm just going to say it's 0.09, and then the power is just the number of years, 25, negative 25, because it is a withdrawal. Then divide by 9% over 1, which is just 9%. And this says I should start with almost $500,000. So 491,128.89. Should be the initial amount in the account. This time the rounding worked out nice. I didn't have to do anything special, just accept the number they gave me. So that's approximate, because there were some fractions of a cent there. What is that amount? That's the initial amount for the account. So initial amount is $491,128.98. And I need that initially in my account if I'm hoping to withdraw 50,000 at the end of each year, every year for 25 years. And again, one thing about these accounts, the spreadsheet has a little flag to say, are you making or pulling the money at the beginning of the month or the end of the month? Our formulas here are designed to use the end of the month. So these are always end of the year, end of period calculations is the assumption. The formula is a little different if you assume it's the beginning of the year or the beginning of the period, but we're always assuming end of period payment or end of period withdrawal. All right, not quite done. How much total money is the $50,000? So let's figure that out next. So again, what's happening? So we looking at it holistically. So let's say somebody gives me this much money. If they do, and I have an account that pays 9%, at the end of every year, I get $50,000. And after 25 years, the account will be empty. Right? So what am I actually getting? Well, I'm getting $50,000 every year for 25 years. So that's just 50,000 times 25. Let's see what that is. So that ends up being $1,250,000. Holy crap. $1,250,000 is what I ended up withdrawing from the account. How did I end up withdrawing so much? Well, this initial amount collected 9% interest for a whole year before I even touched it. Okay, so 9% is close to 10%. This is close to 500,000. So 10% of 500,000 would be like 50,000. So in the first year, the amount of interest the bank had to pay me for having that in there was almost what I pulled out for just the first year. Now I pull out that, and now I have less money, but it's still a lot of money that's going to collect interest over time. And it turns out that that reduced amount over time still collects a crap load of interest because I ended up withdrawing over $1 million out. How much interest did they end up paying me total? Well, that would just be the difference of these two numbers to get the interest earned there. So over on my spreadsheet, on my calculator, and again, we could do this in a spreadsheet, I would just take my 1,250,000, subtract what I started with, which was that 491,000, 491, 128, 198, which means my account over that time while I was withdrawing $50,000 a year earned $725,000. It earned in interest over that 25 years. Most of the interest was accrued in the beginning of that 25 years, and it kind of got less and less over time, but it's still a ton of money. Squeeze this in the bottom. I'm going to put it in red because it's just remarkable. I mean, 1 million, that's a lot of money. Finances are interesting. So the total interest earned, is just the difference in those two, which the spreadsheet or the calculator graph does that amount. Again, that's a dollar amount. $758,871.02 earned in interest. Remarkable.